Copyright the University of Auckland. All rights reserved. The content and delivery of lectures in this course are protected by copyright. Material belonging to others may have been used in these lectures and copied by and solely for the educational purposes of the university under license. You may record the lectures for the purposes of private study or research, but you may not upload onto any third-party site, make a further copy, or sell, alter, or further reproduce or distribute any part of these lectures to any other person. Failure to comply with the terms of this warning may expose you to legal action for copyright infringement by the copyright owner and/or disciplinary action by the university.
Nā mana, e nā reo, e te iti, e te rahi, e nā matoaka o nā topita o te ao, piki mai, kaki mai, nau mai, haere mai ki tēnei o nā wananga. Whakatau mai, tēnā koutou katoa. Good evening, I'm John Fraser, the Dean of the Faculty of Medical and Health Sciences, and it is my very great pleasure to welcome you all to the last of our 2019 inaugural lecture series for the Faculty of Medical and Health Sciences. Over the last 4 weeks, we have introduced a record 8 new professors to the University of Auckland, and I am delighted to say that 4 of our new professors this year are female. For those who are new to an inaugural lecture, I would like to explain just a little about the ceremonial lecture and why we consider it to be one of the highlights of our academic year. The process of inauguration to professor serves 2 very important purposes. One is an expression of acknowledgement and congratulations to the new professor on joining the elite circle of the university's professoriate. The second purpose is to showcase the subject and the story of the new professor to the public. It is the maiden lecture of an academic that has been bestowed with the highest rank of the university. Inaugurations date back to medieval times when universities were elite live-in men's clubs. Entry into the club was a public event, unashamedly designed to impress the public and rich benefactors about the need for their continued patronage, ensuring that club members enjoyed a lifestyle befitting their perceived status, knowledge and intellect and free from outside interference. In this respect, not much has changed. Then, professors were chosen primarily for their own financial worthiness or the deep pockets of their benefactor. And one tradition was that the new professor had to entertain all the colleagues at their own personal expense during the entire inauguration period. I'm pleased to say, Richard, that we're paying for the food and drinks. Promotion to professor is, however, a serious business, and appointment is achieved only after decades of work as a teacher, mentor, researcher, writer, and significant service to the local and international community. The selection process involves intense scrutiny from international peers who confirm to the university that the appointee meets the required level of international eminence in their chosen field. These lectures are a wonderful opportunity for colleagues, family and friends to share in the journey that has led to academic success. And tonight it is my very great pleasure to introduce our 8th inaugural lecturer, Professor Richard Douglas. Richard holds the Garnet Pass Chair in Otorhinolaryngology. I would first like to invite Professor Philippa Poole, the Head of School of Medicine, to the rostrum to introduce Richard.
Ena mana, ena reo, ena karangatanga maha, tēnā koutou, tēnā koutou, tēnā koutou katoa. I'd like to add my very warm welcome to you all tonight, especially to Lily, Chriselle, and to Jeff, and Richard's many friends and colleagues. It's a really special privilege to have been asked to do this role for Richard tonight. Richard and I were students together nearly 40 years ago in the Robb Lecture Theatre not too far from here, but since that time our paths have been very closely intertwined. As a student, Richard really stood out. He was tall, handsome, gracious, generous, clever, courageous, all those same traits that so endear him to us today. We all thought him that one very likely to succeed, as did the medical school, which awarded him the Rotary Prize for the most distinguished medical graduate. Now, Richard has followed a very unusual career path, being fully trained in both medicine and surgery. He completed an MD on human growth hormone and insulin-like growth factors, supervised by a surgeon, Professor Jim Shaw. We physicians were highly delighted when Richard decided to train in general medicine and immunology, and he earned his FRACP in 1997. He worked alongside us at Auckland City Hospital in both general medicine and immunology, and was clinical director of the immunology service for about 4 years, and then he decided to embark on formal surgical training and specialising in ORL. So Richard then became Fellow of the Royal Australasian College of Surgeons in 2004 and is a very highly respected surgeon working in several places. Trainees, I think you should just take note of this career journey, because there's no one specific career path to a successful career. Richard then found his way back to his alma mater and the doors of this institution in 2008 when he was appointed senior lecturer in the Department of Surgery. He's relished this academic role and in 10 short years has progressed through to become a professor and now head of the Department of Surgery, and he follows in some very big footsteps in that role. In his career, he's published over 100 papers and is a world expert in the role of bacteria in sinusitis, about which you'll hear tonight. He's a renowned supervisor of doctoral students and trainees in rhinology from all over the world. He's revamped the teaching for medical students to make it much more relevant and interesting. Many of you will know of Richard's photographic ability and his beautiful photographs, particularly of nature, which give us all a lot of pleasure. However, it's my duty to warn you that Richard's clinical interest is in a part of the body that's got a lot of mucus, quite bloody, and quite lumpy. And I know my colleagues in medicine find sometimes the lunchtime presentations rather hard to stomach. But Richard assures me that he's taken very good care in his choice of slides tonight. Richard, truly, seriously, we're very grateful, very proud to have you in our midst. Congratulations on your career achievements to date, and welcome to the Professoriate.
Philippa, thank you very much indeed for those kind words. Dean of the Faculty, Dean of the School, colleagues, friends and family. It's an absolute delight for me to see you here. Thank you very much indeed for coming. Today, I would like to tell a story, and it's really about the truly miraculous things that you can see inside a nose if only you look. Because, no, seriously, the reality is that within the sinonasal cavity is more immunological, pathological, microbiological marvels than you could ever conceive of. And it never ceases to amaze me just how much pathology is generated in this area. Now, this is endoscopy of the normal nose, and you can see the turbinates, septum, a little bit further back, the soft palate, and this is how that normal nose would have looked on a CT scan. The sinuses are air-filled cavities just below the brain, between the eyes and below the eyes. In normality, the sinus mucosa is so thin you really can't even see it on a CT scan. You just go from the white of the bone to the black of the air of the sinus. Now, this is how very many of my patients look. And this is a case of fairly florid nasal polyps. And this is how that patient's CT would look. And that's a truly miserable condition. It affects a lot of young and middle-aged people, and it really, really detracts significantly from their quality of life. Now, the marvellous thing about nasal polyps is you can do this with them. You can do this in the clinic, you can do it in theatre, and you can remove a specimen. No. Look, no, I've been told I've got to pass on the gory stuff. There's lots more mucus now. I've just actually met Professor Fall, and I was here. There. I don't want any reprise of what happened on Monday night, because the CBR had one of his wonderful Thank the Donor evenings. And while one of the neurosurgeons was talking, not one, but two members of the audience collapsed. And so we had to send off an ambulance full of his audience. So none of you do that. So Alistair's just told me, so I've just gone through all my clinical slides really quickly. The mucus, however, is really important. It makes patients miserable. It goes down the back of their throat. They inhale aerosolized mucus that has a significant impact on the lower respiratory tract. Why do we really need to know about the microbiology of this condition? Because we treat it with antibiotics. Huge amounts of antibiotics. Chronic rhinosinusitis is one of the most common causes for the prescription of oral antibiotics today. These are data from the US. This is a percentage of adults who left a consultation with a script for antibiotics. Sinusitis is at the top, chronic rhinosinusitis, 7% of all scripts. But you can't cure this disease with oral antibiotics. What impact are you having on resistance in the community with all of these antibiotics? And there's increasing data now that all of these antibiotics may in fact be having an impact on the immunology of our sinonasal mucosa and maybe on our gut as well. So the sort of the basic paradigm of how we look at this condition is that you have the mucosal surface, it's got bacteria. The bacteria in some way influence the mucosal immune response. And so you can build up a picture which looks something like this. The microbial community that's living in the sinonasal cavity, the host immune response, the epithelial integrity, because this condition really knocks around the function and the structure of the epithelium. But then we alter it too. By the time I get to see these patients, I've usually had it for 10 years. They've had lots of antibiotics, lots of topical and systemic steroids, and often previous operations. And all of these factors influence how that disease behaves, and all of them influence one another. Are we influencing in our population the immunology of our sinonasal mucosa? Well, the answer is almost certainly we are. It's a bit like climate change, it's obvious. And I'll show you the data. That's Jonathan Bostock. And he was a physician who worked in London at the turn of the 19th century, so nearly 200 years ago. And he wrote the first description of allergic rhinitis in English. And he was describing very clearly, very passionately, allergic rhinitis symptoms because they were his own. He was really interested in this condition, but it took him another 10 years to find 28 patients. It was unbelievably rare in pre-industrial England to develop allergic rhinitis. I don't know, there's more than 100 of you. There's more than 28 cases of allergic rhinitis in this audience tonight. The prevalence in Australasia is about 20%. And this is how it's changed over the last century or so. In all of the developed countries in which there's good longitudinal data, there's been an incredible increase in the prevalence of this condition. And it started in about the 1950s. It seems to be tailing off now, but it didn't happen in the rural South African population. What was introduced in the 1950s? Antibiotics. Yes. and other things. But it would seem that antibiotics are probably, the most likely influence on I think, on what's happened over the last 50 or so years. Louis Pasteur published his germ theory in 1877. Now, before that, nobody had a clue as to how we developed bacterial infections. The prevailing theory at that time was the same as Galen's, which was you inhaled a miasma off decaying material, and that's how you got things. And so this absolutely clarified the relationship between bacteria and illness for very, very, very many illnesses. And this was sort of further made more rigorous by Robert Koch a few years later, where everyone who had the disease had to have the bug cultured from it. You had to have a pure culture of the bacteria, and if you re-inoculated that bacteria into the host, or a susceptible host, they got it. And that's how you made it clear that bacteria caused disease. But the difficulty with chronic rhinosinusitis is that there is no bacteria which in any way satisfies Koch's postulates. And so we're not absolutely sure of the relationship between bacteria and the disease. And it's not for want of trying. For the last century, people have been culturing all of the stuff what's up our noses and growing it and identifying it. What's absolutely clear is that there is a zoo even in the normal sinonasal cavity and absolutely in the diseased sinonasal cavity. Not all can be cultured because some are really fastidious, they're anaerobes, or they're difficult to culture for whatever reason. And not all of them, obviously, are pathogenic. So how do you tease out this mystery? And what's happened over the last decade or so is that the molecular microbiologists have had just this absolute revolution in their technological ability to determine what bugs are in your nose. And they do it not by culturing, but rather identifying the bacteria by their DNA. Because obviously each species of bacteria has got its own DNA pattern. And what they do is they cut out a segment of DNA. It's a particular segment called the 16S segment. It's very highly conserved for each particular species. And then once I've got this segment, they amplify it, and then they sequence it, and then they compare it to a database which has got all of the sequences of all of the bacteria known to mankind. And by that way, they're able to identify which species are present in a particular sample. And so the question has to be asked, how did somebody who grew up in an otherwise entirely normal and happy family become interested in this? and I am, as you probably guessed, I'm the distracted one who looks a bit disgruntled. But then I ate a lot and grew. That's my older brother Jeff, who's here tonight. And then I went to Auckland Grammar, grew some more, developed terrible acne, learnt lots of Latin, and then I went to medical school. That's class of 1980 we started, with a number of you who are here tonight. And you've been such great friends and colleagues over my career. And as a trainee intern in my 6th year, I spent 3 months in South Africa, and I worked in Baragwanath Hospital in Soweto. This is a massive hospital. It's got 2,700 beds, and it had at that time about 3,500 patients. They used to bring out mattresses and put them between the beds so the patients had somewhere to sleep at night. And every night we admitted about 100 to 120 surgical patients, nearly all from penetrating trauma. And it was really like working on the periphery of a war zone. And it was the first time as a naive New Zealander to see just how much politics and history mean in some societies, and just how lucky we are to live in an incredibly stable and sensible society as we have in New Zealand. And then I came back and I worked for this man, Professor Jim Shaw, as his house officer. And, and with these two, Matt Wildbohr and Dave Humberstone, who unfortunately are no longer with us. And we had, during that 3 months, I think we had as much fun as you can possibly have while working absolutely all the time, which is what we did. And, or almost all the time. And then Jim said, come and do an MD with me. And I think it was come and do an MD with me, comma, boy, as I recall. It'll be great. And so I did. And under Jim's supervision, I did an MD in Peter Gluckman's lab and frankly learned a huge amount and published some papers and really got to know a bit about how research and academic work goes. It was, I must say, enriched, but that was a hard time to be in clinical research. The Cartwright inquiry was at its height. And anyhow, look, I ended that time unsure in my own mind as to whether I wanted to be an academic general surgeon. And so I left the country and I got a job in medicine in England, in Southampton General and Bournemouth General Hospital, and drove a lot through the New Forest. And met while I was there a friend of a friend who was an Australian who was a clinical immunologist and allergist at St Mary's Hospital. And she said, why don't you be a clinical immunologist and allergist? Far better than falling around in the middle of the night doing surgery. And she seemed quite happy in a lot. And I thought, all right, I'll do that. And so I came back and I was a registrar for a few more years at Auckland doing medicine and frankly enjoying it, if the truth is known. And then she fixed me up with a job with her mentor at the Alfred Hospital in Melbourne, and I went and did a fellowship there for nearly 2 years. And then I came back and was involved with this sort of thing. And allergy was actually really pretty exciting then, because Th1 and Th2 was just becoming a thing. And these charts, which, you know, beloved by some and understood by fewer, were all the rage, but at the end of the day, you give them all prednisone, for goodness sake. But that's what I did, and that's what I was interested in. And frankly, it is actually, if the truth is known, it's really interesting. And shortly after I came back, I had the very, very good fortune of marrying my lovely wife, who's here tonight, Griselle. And that's her in India. We just had a holiday in northern India a few months ago. And I got a really nice job at Auckland Hospital, and it was half-time clinical immunology and allergy, and half-time general medicine, which I also really enjoyed. And I had wonderful colleagues, some of whom are here tonight. And frankly, it was great. And I'd do ward rounds and have medical students and, opine and such like. And anyhow, what then happened is something which I'm not absolutely sure of. But I had this irrational feeling I should be doing something slightly more tangible, and which got stronger and stronger. And I thought, I actually need to do surgery. Now, the problem there was I was 39 and established after a fashion. And anyhow, my wife was up for it. So I turned our lives upside down. That's her in a jet trainer over the Murray River. And then, so I went from being a physician here to being a basic surgical trainee in Dunedin General Hospital, public hospital, which was a significant transition. And it wasn't, if the truth is known, it's not loss of status. I tell you, it was loss of competence. Because I went from actually pretty much knowing mostly what I was doing to absolutely not knowing what I was doing, and that was really, really hard. And also falling around in the middle of the night, doing appendixes, all of which were open in those days, at the middle, and it was teaching an old dog new tricks. But anyhow, be that as it may, I soldiered through that and then got accepted onto the ORL training scheme. The ORL surgeons a number of whom are here tonight. I'm absolutely delighted to see you. Took me on as a recycled physician and thought they could see promise. And at that stage, I was older than most of them. But they trained me, and they've been amazing. They really have been amazing colleagues. They were amazing mentors. They're amazing colleagues since then. This is Bill Baber. He's here. He's Auckland senior otologist. He is the epitome of a gentleman surgeon. And I'm very, very pleased to have you here tonight. Now, I am, because there's nobody else who could be possibly this disorganized or have this lack of foresight or planning. I am one of the very few people who have gone through all of medicine and all of surgery. And so I can tell you what the difference is between the two. It boils down, and because I actually know there are one or two secret physicians, surgeons who would really, really, really wonder if they should have been surgeons. The difference is, surgeons have much more fun. Seriously, they do, I think. They really do. But they pay for it. They have actually some really terrible times, because there's a lot of falling around in the middle of the night, and there's stuff that goes really badly wrong. And unfortunately, you're very directly responsible for it, so it is quite difficult. Surgeons, I reckon, know much more than physicians think they do. No, quite seriously. And the only people who know more than all of us are the anaesthetists. Because they see all and hear all. But the one really major thing about the difference in training is actually the exit exam. And that makes a huge, huge, huge difference. That's really tough. It takes about a decade after you've gone through it to stop having nightmares about it. And frankly, that's if you pass it. If you don't, you're slightly damaged forever. But what I wonder is whether the physicianly specialty shouldn't have an exit exam so that their trainees can demonstrate their prowess, their knowledge, and their competence at the end for each of their specialties. But anyhow, that's a thought about the difference between the two. Now, I finished my training, fortunately passed the exam. Will never do any more. And then had the very good fortune of going to Adelaide to work with this man who's in the centre. He's showing to neurosurgeons how to do it, which not many people ever have the possibility of doing. And he is PJ Wormald. He has made great inroads, I think, in endoscopic sinus surgery. And I was very fortunate to learn how to do it under him and under his colleague, Steve Floriani. And then in 2006, I came back and I got a job at Auckland Hospital and at North Shore Hospital, and I was exceptionally happy doing sinus surgery. And this is my little domain. It's everything that you can get to with an endoscope in there. And there's just so much fascinating pathology, and I've really, really, really enjoyed operating on it. And I've got to, because it's got neighbouring bits looked after by other specialties. The ophthalmologist, and I've worked a lot with Richard Hart, who is an oculoplastic surgeon, and we've looked at, on to the next one. That's how she did look. That's after the pus had been taken out, because that's sinusitis, which has got into the orbit, which makes you desperately sick. And with the neurosurgical team, and we've done some fantastic and fascinating cases, and it's been really, really interesting seeing how they manage conditions. That's a very, very difficult subspecialty, because the possibility of really, really difficult complications occurring when you're on their side of the dura is much, much higher than on our side. And there are a number of pathologies which are not inflammatory in the sinonasal cavity, and they grow in an area of the interface between the orbit and the skull base. And so sometimes They can take them out like pituitary tumours. I'll take them out transnasally, in which case I become an expensive scope holder. Or sometimes I'll do an external approach through a craniotomy, and I'll meet them in the middle with the endoscopes. A really, really good thing about surgery is it's a team sport. And over the years, I've worked with fantastic groups of nurses who have been so patient and supportive, and wonderful anaesthetists. And they have this incredible calming sort of thing about them in theatre, and it's wonderful. But they provide hypertensive anaesthesia for me because the nose is so vascular that unless the blood pressure is really low, the patients bleed and it's really hard. But they're far less relaxed than they appear, and they are really, really working hard. And they've provided, frankly, brilliant support and companionship over the years. And all the registrars, they've been great. It's quite a hard job being a surgical registrar. They work really, really hard. They're all so energetic and enthusiastic and frankly impressive. But what really impresses me is in the last 18 months or so, for some of them it's the last 12 months, which I think is a mistake, they've got to study for their exams. And so they work all day, half the weekend, and then all night. And there's no guarantee of passing the exam at the end. And they all seem pretty cheerful. And I think that is a great testament to the strength of their character. And then there are all the fellows we've had. Every year since 2010, we've had a fellow, a rhinology fellow. We've had people, we've had New Zealanders, and they've subsequently gone on and done great things in other centres in New Zealand, which is brilliant. I've had Australians, we've had Chileans, a couple from the UK, Singaporean, and an American, and a Brazilian. And they've all brought so much, because you get this person who's a fully trained surgeon, and they're really, really enthusiastic, and they've often worked with really, really good people, and you learn a huge amount from them. I think all of our services have learned, all of us in our service have learned so much from the fellows, and they've gone off to do fabulous things. But that brings me back to the central subject of this evening, nasal mucus. And coming back to the Department of Surgery. Because I came back in 2006 as a senior lecturer. I was warmly welcomed and greatly supported by John Windsor and Ian Bissett and Lois Blackwell, a wonderful PA. And you can see Ian's smile, and Ian's smile now is permanent. And he has, ever since he stopped being HOD, he hasn't stopped smiling like that. But they were great, and they have, the Department of Surgery was a solid network which I could sort of graft onto. But I didn't have a team at all until Andy Wood, who was an ORL trainee, and he came to me one evening and he said, I'd like to do a PhD. And so we found him some funding, thank you very much to Green Lane Research and Education Fund. And he was unstoppable. And he was a brilliant first PhD candidate because he did absolutely everything. And he had to because there was nobody else to do it. And he did, well, I'll show you what he found. Because what we're doing is doing really careful microscopy. So we wanted to see the relationship between the bacteria on the surface and the inflammatory response below. And a year or two before we started this work, a Swiss group had found some Staphylococcus growing in the epithelium. And Andy replicated these observations, and there's Staph aureus in the epithelium, growing in the epithelial cells. But what he then did was observe microcolonies, small groups of bacteria growing in the interstitium. This had never been seen before. And here's our very finest example of one of these, and you can see that microcolony in the interstitium of a patient with chronic rhinosinusitis. Now, the truly, truly remarkable thing about these bacteria is that they are not initiating any immune response. But it's not a microabscess, it's a microcolony. And Staph aureus, as most of us know, when we sort of think it in pathological terms, whenever you get a Staph aureus collection, it causes a very vigorous inflammatory response. And so that was a really, I think, remarkable observation, and one which we're still, frankly, trying to understand the cause of. Clearly, the Staph aureus was eluding the local immune response. And it was followed a couple of years later by Ray Kim. Ray is also an ORL trainee. And Ray was particularly interested in cystic fibrosis. And you get really sticky, horrible mucus in cystic fibrosis. They get it in their lungs, which is why they have terrible lung disease. It's very hard to treat. Now, Andes microcolonies were few and far between. We could find them even if we looked really, really, really hard, and only about half of the patients. And they were little. That seemed under low power. In cystic fibrosis, you find them in nearly all of the patients, and they were everywhere. The mucosa was full of bacteria. Again, an observation never made before. And this idea of having bacteria in the mucosa which doesn't cause an inflammatory response may well be the cause of the resistance that this condition has to antibiotic treatment. And here's a mucosa of a young boy who's about 14 at this time. It's endoscopy. He's had the medial wall of his maxillary sinus, so we're looking into it, taken away. And you can see the involvement of the maxillary mucosa. And I think this is my last one, Alistair. And that's him a few years later. That's how that condition progressed. And you can see, oh no, we're going on. You can see how difficult that sort of stuff is going to be to fix with antibiotics. This is why you need to you need to surgically remove it. Ravi Jain, another ORL trainee, came along a little bit later, and he was interested in the response of the microbiome being all of the bacteria that grow in the sinonasal cavity, which you can identify by molecular techniques. And he looked at the effect of antibiotics directly and also of surgery on the nasal microbiome. And in this study, he had 23 patients, and that's the microbiome of all 23 of those patients. All microbiomes of all patients have got a slightly different composition. And then he looked at them again 3 to 6 months later. And although that's a really complicated slide, but it's got a bottom line, which is the amount of Staphylococcus that we found afterwards was way more than we found before. And most of these patients had done really well, and it was exactly what we weren't expecting to find. And this is often the case with doing these sorts of experiments, that what you find is not what you expect. And so you need to do another lot. This is Mike Hogarth. He's a scientist. He did an honours degree in Mike Taylor's lab down in SBS, and then he wanted to do a PhD, so he came and joined our group, and he's just got his PhD a couple of weeks ago. And he looked at the difference in microbiome between different subgroups. This is the average microbiome of a whole lot of normal patients. Those are all of the bacteria genera that you can find in a whole group of normal subjects, averaged. Here's the microbiome of patients with CRS, but without asthma, and it's really not so different. Here's the microbiome of a whole group of patients who have got CRS but have got asthma. A little bit different, but these patients are worse. Why are they different? Possibly because they're getting more antibiotics. Here's the CF patients. Wildly different. Lots of Pseudomonas, lots of Fusobacterium, that's an anaerobe, and lots of Staphylococcus. Why are they hugely different? Not only in the species, but also you can see they've got far fewer of those horizontal bands. They've got far fewer different types of bacteria growing. And almost certainly that's because the CF patients, who are all adults, have, since childhood, had multiple courses of extremely potent antibiotics, which have probably pretty much wiped out all of the normal commensal bacteria, which you can see in normals. And it may well be that having those commensals keeps you healthy. We were then joined by Brett Wagner. Brett's another scientist who did an MSc in Mike Taylor's lab. And she could see the limitations of the 16S technology insofar as you only find what you look for. You have your primers, which will get out the 16S segment, which only occurs in prokaryotes, only occurs in bacteria, and you won't see any of the other DNA which is there. Now you can expand that. You can look at the 18S segment, which occurs in eukaryotes, so in fungi or in human cells, but you're still only looking at a tiny, tiny, tiny segment of the DNA in each of your samples. Or you can do what she did, which was do a metagenomic analysis, and that's where you sequence all of the DNA in your specimen. So she got nasal mucus and sequenced everything. And what we thought was that there'd be really quite a lot of bacterial DNA in the nasal mucus, and there's not. 99.99% of the nasal mucus was, in fact, human. Only 0.01% was bacterial. So that puts all of the other results into perspective because everything had been looked at. And that's an extremely powerful technology, and that's going to, I think, unlock a lot of the mystery of this field, or many of these fields where conditions are caused by not one bacteria, but by many. If there's one single bacteria for chronic rhinosinusitis which fulfills or gets close to fulfilling Koch's postulates, it's Staphylococcus aureus. And so it's taken a particular interest in this bacteria and has got a whole lot of pure cultures from patients with sinusitis. And instead of just looking at the 16S, has looked at the whole genome. And this is a very pleomorphic bacteria. It can do all sorts of things because 20 or 30% of you will have it in your nose right now and could be cultured from your nose right now. But it's doing nothing. It's just part of your normal commensal environment. But if given the right conditions, and if for whatever reason that bacteria in your nose starts producing exotoxins, it can make you desperately unwell. It can have you in critical care within 24 hours if you have toxic shock syndrome. And so there's a lot more subtlety and complexity to Staph aureus than how clinicians usually see it, because this is how we see it. We get a culture Staph aureus, and so we give flucloxacillin. This is Christian Lux. He's a German PhD who started work about 18 months ago with the team. He's doing a big meta-analysis of antibiotic use. He's actually got into concertos and a phenomenal amount of interesting information from the community dispensing. You can find out whatever every patient has taken. And he's compared the antibiotic use with the microbiome. And he's also done a study of an antiseptic spray, because I think that we need to have different ways of killing bacteria other than using antibiotics. And he's done that in the post-FES. So instead of using antibiotics in the immediate post-FES phase, you use an antiseptic. Joey Sue, who's not here tonight, she's always late. Oh, she is. No, she's on time. She's another ORL trainee, and now nasal sprays, they're all designed to treat allergic rhinitis with an intact nose, but we use them post-operatively in patients who have completely had their nasal anatomy transformed by the operation. And so where the spray goes is entirely different, but you need the spray to go everywhere so that you don't get recurrence of your nasal polyps. And this is one of her early experiments where she's put some dye in a spray and sprayed it and looked at where it goes, but it's extremely hard to do this sort of thing, and it's hard to quantify. And so she's been working over the last year or so with an extremely talented biomechanical engineer, and they've been in RMIT in Melbourne. And they've been creating models. And that shape you can see there is the inside of a nasal cavity, which Joey's made from a whole series of CT scans. And that's somebody who's had sinus surgery, which is why all the holes into the cavities are big. And then Kiao, who is our collaborator, has a program which shows into that cavity exactly where the drug goes when you squirt it in. And you can then do virtual experiments because you can decide whether you need bigger particles or smaller particles or faster particles or ones with a wider spray. And that's what Joey's working on now. And this sort of perspective has made us change, or made me change what I do. And with a biomechanical engineer just down the road, we developed this little cap which fits on the end of an inhaler. When you squirt out a nasal spray, the little particles are between about 50 and 100 microns across. When they squirt out of an asthma inhaler, they're about 20 microns. What we've found with CFD that you want your inhalers to be, your inhaler particle size to be about 10 to 20 microns. You don't want them to be as big as a nasal spray. And so that's why we're using the asthma inhalers. And that seems to be going well. And those are just 3D printed. Terry Yin is another ORL trainee. Now he's taking a slightly different tack. He's working with Maurice Curtis's group because Maurice came to speak to us about Parkinson's. And he said that the first symptom that most Parkinsons have before they have the motor problems that characterize that disease is hyposmia. And that predates the motor symptoms by about 7 or 8 years. And so he said, there's something going on with their olfactory epithelium. And so what Terry is going to do is sample the olfactory epithelium. And this is not us, this is another group who have described the technique, and that's right up in the olfactory epithelium, taking a little bite of it, and you can get that really numb with topical anesthesia. So we're going to sample patients with Parkinson's and their partners and determine whether the microbiomes and the histopathology is different in that slot where the olfactory mucosa is. Now, Satya is known to many of you because she's been providing histopathological assistance to a number of PhD students until finally, I think she got sick of helping everyone and said, I want to do one myself. And so she's doing one with the group, and she's got a really, really interesting topic. There's a huge change in the structure of the mucosa of the sinonasal epithelium when you get sinusitis. And surprisingly little is known about this. And Satya read hugely about the topic. And she's going to do her study on telocytes, which are really complex cells which go through the interstitium of the submucosa, and they touch a whole lot of other cells, and they're almost certainly controlling both the inflammatory response and the healing response. And virtually nothing is known about them. And this is one of Satya's early slides of a telocyte. Now, James Johnson is also an ORL trainee, but he didn't want to do rhinology. He wanted to become a pediatric ORL surgeon. And so he didn't look at the nose, he looked at the tonsils, which are almost as fascinating as the nose, but really, really important to know about the microbiology because lots and lots of antibiotics get taken for tonsillitis. And he and Murali Mahadevan, pediatric ORL surgeon at the Starship, took out a whole lot of tonsils and they looked at them really carefully. And the particular area that they were interested in were the crypts, which all of our tonsils have got crypts, or very thin tunnels which go into their centre. And what James found in the depths of the crypts were microcolonies of bacteria. And again, the immunological response to those microcolonies are, these are extramucosal. Well, lymphocytes, B lymphocytes and T lymphocytes were being drawn into an extramucosal space. Now, that's an unusual reaction. So there's lots more. I'm still trying to sort all of this out. There's lots more to be learnt, I think, about what's going on. He did a randomized controlled trial where he got 60 children who were about to have a tonsillectomy, 30 got Augmentin and 30 got nothing. After no antibiotics, that was the microbiome of the 30 kids. There was lots of Haemophilus and lots of Fusobacterium. If you got Augmentin, there was virtually no Haemophilus, but there was lots of Fusobacterium, which had just taken over. And I think this is probably what happens when we take antibiotics, is that we sort of clear the way for the growth of something else. And you certainly don't stay, well, A, you don't achieve sterility, and B, you don't, if you do, you don't stay there for long. Anna Vesti was a technician at LabPlus, and she came to the group and said, I want to become a molecular microbiologist. So she did a PhD and looked at the microbiome of the oral cavity of patients who have just had radiotherapy to that region. And they often develop mucositis, which is a really disabling complication of that treatment because it can stop you from easily eating or drinking. And what she found was that with more severe cases of mucositis, there are a whole lot more gram-negative anaerobes. And she's just completed a randomized trial looking at probiotic. This is one developed down in Dunedin. It's Streptococcus salivarius, which is a very benign bug to have in your oral cavity. And so the results of that study, I think, will be really interesting. And finally, we've got Christy, who is here tonight. And Christy is our wonderful postdoctoral fellow. She's continuing James's work. She's looking at the actual composition of the microcolonies. It's really, really, really hard, because these things are very small, to culture them, to actually get to them in a sterile manner and to find out what their composition is. And Christy can do that. And she laser microdissects them. She mounts them on a Teflon slide, laser microdissects the microcolony, and then it falls out, captures that tiny sample, and then does the 16S analysis of it, and so identifies the DNA of all of the bacteria that are in that microcolony. And he's done that to a small number of microcolonies so far, and 2 of them have been full of staph and 1 full of Fusobacterium. So I think this technology is an incredibly impressive one, but also really powerful for identifying intramucosal bacteria. And I think we've got a huge amount to learn about these. Christy's also been absolutely wonderful at looking after, helping, encouraging all of our wonderful BMedSci honours students. And we've actually had slightly more than that, and I'm really embarrassed to see Tim. And because Tim's not here, because I couldn't find a photo of you, Tim. But he did one, and Terry's also not here, and it's really lovely to see the BMedSci honours students come on. No, you're not on the photo. But to come and then come back and do a PhD. And one of the great joys of doing research is working with collaborators, and we've had wonderful collaborators which have really expanded our horizons from this institution and from others nationally and from several internationally, and that's been an absolutely, just a wonderful part of doing this research. And being involved in academia has enabled me and Chriselle and Lily on occasion to travel extensively, and that's been wonderful. These are the Annapurnas in Nepal. It's Durbar Palace in Nepal. That's unfortunately, they got really knocked around with the earthquakes. Hagia Sophia in Istanbul. That's Atacama in northern Chile. It's a beautiful place to go. That's in Oman. And that's in Mandalay in Burma. And I've also had the opportunity to operate in a number of countries, particularly in Asia, because with endoscopic sinus surgery, because it's all videoed, your audience sees whatever you see. And so you go to these courses in India and they'll have up to, I think the maximum is about 800 people watching what you do. And they seem to really love it. There is so much pathology, and it's so gross compared to what we see. This is a poor woman. That's a benign tumour. It's an inverting papilloma. It's sort of like a big wart, if the truth is known. But you can see it's so big, it's growing into a mouth for goodness. And she was just losing weight because she couldn't eat. And all of that can be taken out with the endoscope. And what I really admire is with absolutely nothing, these so many surgeons in these countries are doing truly miraculous work. That's a recovery in the Ear, Nose and Throat Hospital in Mandalay. And here's the team. This is in Hyderabad. This is earlier this year. I try to fit in. I don't. The harder I try, the more epic is the failure. This is in Riyadh. That was a real, if you ever get the chance to go to Saudi Arabia, say yes. It's a fantastic place. I also, because I am finishing up now, I have to thank the Garnet Pass, Rodney Williams and Garnet Pass Memorial Foundation. This is an Australian-based foundation. An Australian widow of an ORL surgeon gave a very generous bequest, and that Philippa mentioned has funded the chair in ORL, and the foundation also funded a number of the PhD students, and they have been an unbelievable support to us. Now I also have to thank my wonderful team at Maranui Clinic, my private practice, Jenny and Melissa, who do a great job of running my practice and helping me with it. And it's also a real powerhouse for research, because lots of my private patients get involved in my research, and that's a really terrific way of recruiting people. And you can come and park there, and it's really easy. It's sure not at Auckland Hospital. And to the wonderful friends who have supported me over the years, to Stella, who's come back specially from Australia to be here tonight, and to my mum and dad, who would have loved to have been here tonight, who were phenomenally good to me, and patient, and generous, and to my best friend and lovely wife, Chriselle, and to my lovely daughter, Lily. And look, that's the end of my lecture. Thank you very much indeed for your attention.
Well, thank you very much, Richard, for what I think we would regard as one of the most revealing lectures that we've witnessed for some time. But truly a tour de force. I mean, for somebody to have gone first through medicine and then through surgery with the level of commitment to academic medicine is a testament to your passion for science. And I think it came through very clearly, his love of the nose and all the stuff that's in it, but also the interesting things that happen inside the nose. It is a wonderful opportunity to look at the way in which the human body interacts with the external environment, such as you've seen in some of the presentations that he gave around the immunological response to bacteria. It's something that I'm also very interested in. Richard and I have worked together on some of those projects, and it's been a delight to work with Richard. He's a wonderful mentor, as you've seen, with all the students, just tremendous support for the next generation of academic scientists, clinician scientists. So I think I'd like you all to join with me in celebrating the appointment of Richard to Professoriate of the University of Auckland, and I think you'll all agree that he thoroughly deserves the title. So please join us. There's more nibbles and drinks outside. Don't rush off. And this was the last, certainly not the least, of our inaugural lecture series for 2019. And I hope see you all again next year for the next season of inaugural lectures. So Mā te atua koutu hai manaaki, haere tu atu hoki tu mai, noho ora mai rā. Farewell, I leave you in good health. Good night.
Oh, good Lord. Hey, thank you. That was really well. I appreciate that. Thank you.